Yeah, today our webinar is going to be about how to properly use holiday testing equipment. So I'm very excited. We had a session this morning. It went very well, and we had a lot of really good questions. We like questions, by the way. So please ask questions. The way you do that, we can't hear you speak, but the way you do that, if you'll move your cursor around, you'll see a Q&A icon. So if you'll click on that Q&A icon, you can actually type in your questions. I will be monitoring that throughout the webinar, and we'll ask our speaker, Mark, to answer those questions as we go. So please do that. Also, at the end of the webinar, we're going to ask you some questions. So we'll have some poll questions. It's kind of a knowledge check for you, and we'll give you some time to answer those questions. There'll be 5 questions. They're all multiple choice, and then we'll come back and give you a little bit of time, come back and let Mark give you the correct answers for all of those questions. So also at the end of the webinar, Mark will put up a QR code. A QR code is one where you can take your phone and go to the camera and hover it over the code, and it will actually take you to a website, and we would like for you to do an evaluation survey, so for the webinar. So please do that and tell us what you think. Tell us any comments on future webinars or ideas, anything like that. We appreciate your input. That's very, very valuable to us. So with that, I want to introduce Mark Byerly. Mark is the president and CEO of Tinker and Rasor Corporation. And he's the expert on, I know people hate the word expert, but he is the expert on holiday testing. So a lot of great information this morning. I'm looking forward to it again. Here you go, Mark.
Well, thank you, Tom, and thank PPG for putting the series on. I didn't get a chance to look at the last couple of days, but away we go. I'm showing a poor internet connection, Tom, on your end. I don't know if you see the same thing, but anyway, what we're going to do is we'll go through a slide presentation. Again, I thank PPG. Thank everybody for being in the room today, the virtual room. Hope everybody's staying safe and social distancing and getting out into the sun, going to the park, go and walk around, have a good time. I'll start sharing my screen now. Okay, so on the screen is PPG's opening page, and it is how to properly use holiday detectors and testing coatings for holidays. So the history of holidays, we get asked all the time, where does the term holiday come from? The earliest we can trace it back is to a novel written by Richard Henry Dana Jr., who was an explorer and author who traveled up and down the California-Mexico coast, mapping the coastline. 2 years before the mast was published in 1840. And during these voyages, of course, ship maintenance was a must, as it is today. And he noticed that there was a patch of wood rot in one of the masts. And so he said that the sailor who was in charge of that must have taken a holiday. So this is where we get that term. It doesn't matter now. Steel replaces wood, paint replaces tar, but holidays, however, live on forever. Holidays are known as pinholes, voids, and discontinuities. Tom says if it's big enough to see, it's probably a vacation, not a holiday. So let's go on next. Why do we do inspections?
You might want to swap your display.
We want to ensure the proper.
You might want to swap your displays there, Mark.
Did that do it again?
Mark, can you hear me? You might want to swap your displays where we can see
yes, I got you.
The actual slide presentation.
Okay, is that better? So we do inspections to ensure proper application of a protective coating, to assure that the coating is not damaged during transit, especially when it comes to pipelines or transportable tanks, to verify that there's proper handling prior to burial, to reduce the overall operating costs, especially on pipelines, tank bottoms, where we have cathodic protection applied. We don't have to overdrive transforming rectifiers. Of course, on pipelines to prevent failures, the same goes for tanks, ships. But the number one reason we do it is for safety. So the first thing we do when we get our holiday detector is we want to make sure that we read the manufacturer's instructions. For all the ladies in the crowd, you'll understand what that is. For all the guys, we normally just, I give all my instructions over to my wife, and she's the one that gets the little blinky 12 off of our appliances. So the manufacturer's instructions, however, when it comes to holiday inspection, especially with high voltage, is extremely important. They'll teach you how to properly assemble and use the equipment so it's in safe operating condition when you're ready to go to the job site. Oh, I apologize. I got to back up one. So the first thing we do when we get the kit and we open it up, it doesn't matter whether it's the day we're going to work or the day we receive the equipment from the factory, is we want to make sure that the detector is in, all the parts are there, everything's ready for assembly, and that everything's in good nick or in good shape. So we want to open it up. I apologize for the commercialization of the slide, but I don't happen to have any of our competitors' units with me. So this is why you're getting the Tinker Racer slide. Make sure all the parts are there. Make sure you have everything that you're going to need when you go into the field. Not pictured here would be the electrode of your choice. We also want to make sure that we have proper assembly. Make sure that all the parts go together properly, they fit, and they're in good nick. That you don't have a broken wand handle or a dead battery. We want to make sure that all that stuff is ready to go. So one of the things we want to do is when the coating's applied, we want to make sure that in the plant, just prior to coating or just post coating, we want to make sure that everything is checked 360 degrees in the case of pipeline, on the exterior. Tanks, again, every square inch gets inspected with a holiday detector to make sure that there are no voids, holidays, pinholes. The inspector should measure the coating thickness. This is extremely important, and we'll go through this a lot more during the slide presentation. But we want to make darn sure that when the applicator tells us we have 30 mils or 10 mils on the pipe, that's exactly what we have on the substrate. That we have exactly what they've applied, not what they've told us that they've applied. We had a case one time, real quick story, where we went out to a job that an inspector shut down, and that inspector didn't even have a dry film thickness gauge in their possession. And we found out instead of 30 mils of coating, testing at 3,000 volts, they actually had 90 mils of coating, which would have been a 9,000 volt test, and the arc wasn't big enough in the holiday detector to bridge that air gap. That's why we tell you, make sure that you check, and check in multiple locations on the surface to ensure that you have the proper mil thickness and then proper voltage applied to address that mil thickness. The only way to ensure that you've got the proper and perfect test voltage is to actually create a holiday. So you want to find a spot, create a holiday. We use a very small drill bit, and we use our fingers to rotate that drill bit back and forth until we hit the substrate. Then we run the holiday detector towards that holiday, and we want that arc to jump twice the distance as that coating is in thickness down the hole to the substrate, the pipe, the tank, the bridge deck. So please ask questions during this presentation, because if you don't, these slides are only about 5 minutes long, and we'll be able to go get a cup of coffee somewhere real quick. Tom's ready to field your questions. And
so you want to move your holiday probe over. You want to move your holiday probe over a little bit from the hole, twice the distance of the coating thickness, and be sure you still get a spark. Basically, is what you were saying earlier, right?
That's correct. So what we do is we actually approach the holiday so the arc jumps. Once it's in there, we then retract or move back away from the holiday to make sure that that we've got that twice distance as the coating is thick. That's correct, Tom. So post transport, especially on pipeline, you've got vacuum grabbers picking these things up and dropping them onto trucks and trains, and coating often gets damaged. So we want to make sure that after we get it off of the train, that coating is in good shape, or that we find the holidays. So after the unload, you make sure that every stick of pipe is tested, every tank is tested over the entire surface. grounding and like I said before, we always make sure that we create a holiday on our substrate prior to going full NIC after it. That way we're sure that we have the proper test voltage. Proper to burial or placing a vessel in service, we want to make sure that we've given that final inspection. This really protects the contractor, protects the applicator from coming back, say a post-survey is run, whether it be DCBG on pipeline or a Pearson detector survey. We want to make sure that most, if not all, of the holidays are found prior to burial in the case of pipe. All right, so common missteps. We all want to pay attention here. And again, please ask questions. We really need to stretch this out, so we need some questions. The common missteps, the first one and the most egregious of missteps is ground. We have to make sure that we are grounded to the earth with high voltage or pulse type DC. The substrate needs to be grounded to earth, and then you can drag the trailing wire or the ground wire along the surface if you're doing pipeline, or you can connect it to the substrate of the product you're testing. In concrete, we like to get a hold of the rebar in the concrete, or make sure the external, if it's buried, make sure the external earth is good and wet, and drive a probe rod into the ground and ground to it. Another misstep, sorry, PPG,
So
is to follow the manufacturer's guidelines.
Right.
Yeah, we'll talk about how we don't play with the new guys a little bit later on. But the manufacturers come up with their specs, and we'll talk about it a little bit later. Yes, question.
It says, will you be discussing how to establish a ground, especially on concrete? I think you may have alluded to that.
Yes, and we'll go over that a little bit more in I think 2 more slides. We'll go over that grounding of concrete.
And then we have another.
Thank you very much for the question. Please.
The next question. Yeah, next question is, how do you determine the proper voltage to use? Okay,
and that's coming up in the next slides. Thank you very much. And if I don't answer it, I have not done my job. So we'll continue with missteps right now, and that is treating SPOs or standards, recommended practices, as if they are gospel. There's only a few 10 items that came off the mount, so those are the only ones you should probably follow instinctively without questioning. But we'll get through SPOs and how to deal with those as well. And then again, not reading the instruction manual that comes with the unit. The manufacturers put a lot of information in there, some safety, some operating. It doesn't matter whether it's Tinker and Rasor or others. So please read and follow your instructions. So as it pertains to, you can take this pipe and you can turn it into a tank. You can turn it into a concrete structure, a bridge. All we're trying to do is show that the proper grounding is extremely important when it comes to using a holiday detector. So in the slide here, we have the 2 earths going, one from the ground and then one from the back of the holiday detector. My favorite way of grounding is to get a good earth ground to the structure, and then you can either ground directly to that. In the case of long line pipeline, we just drag the trail behind it, and it picks up. Tom was talking about telling the new guy on the job to move the trail. So that's kind of a break-in practice that some companies have. They have the new guy go out and move the holiday detector trail as they're hitting a holiday. The voltage goes off the pipe back to ground and up that ground wire, and you'll make that new guy dance every time. So if you can practice good earth grounding, it eliminates a lot of headache down the path. In the case of concrete, if we can't get a good ground to the rebar in the structure, or you can't get a good earth ground outside of a buried structure, such as a wastewater treatment plant, then we can always run a capacitance ground. And the way we do that is we'll take a 6-foot length of 3-foot wide 1/4-inch chicken wire and lay it out on the bottom, put the ground wire down on top of that, and then put wet bags of sand on top of the grounding mat. And it works very, very well. In the case of, you might see sometimes we'll have a silicone rubber mat that's got a high concentrate of carbon in it that we use as a capacitance ground too. It doesn't work as well on concrete. It doesn't have the surface area that the wire and sandbags do. So if you cannot get a good direct ground to the inside of the concrete with a moisture level high enough to pull current, then this capacitance ground wire, sandbag, and ground wire from the unit is just fine. Another question we run into is we always sell our holiday detectors with a 20-foot ground wire. Sometimes people need 100-foot, 200-foot. If they're out in the field and they can't call us up and get one delivered overnight, which is rare, they can always run down to Home Depot, grab some wire, even shielded wire, and run the length of that ground wire. And we don't care if it goes out 1,000 feet. It'll still ground the unit. So
we have a question here.
Please.
Yeah, it says you're showing lots of pipe here, but is holiday testing used on other types of steel, like structural steel beams, for example?
Yes, absolutely. Thank you for the question. So, like I said, you can take these pieces of pipe, and this is a pretty poor presentation for this webinar probably, but you can take that pipe and turn it into whatever you want, as long as it's coated steel or coated metallic structure that'll pass current. Then you can definitely use holiday detection on any surface, any steel surface, aluminum surface that you have a coating on. Okay. So dielectric strength, we go down to number 5 first. Holiday detectors are not dielectric strength testers. Dielectric strength testers are destructive devices that are meant to destroy the coating at a certain level. So you know exactly what the dielectric strength is, or the coating failure will exist with that sort of testing. It's used a lot in determining what the test voltage should be on the coating, but it's not really a good way to decipher whether or not. So always create a holiday to find a holiday twice the distances the coating is thick. It's a pretty simple method and very fast, and it takes into account all the field conditions, weather, humidity levels in that, temperature, always change the way the detector works. So the coatings have an ability to block the flow of electrical current, and it's referred to as the dielectric strength. Dielectric strength of coatings is measured in volts per mil, which is where we get confused on holiday detectors because we always set volts per mil. You can see in this slide that the dielectric strength of air, it takes a lot more air than to get destructive than you can do in a coating. So if there's any questions on dielectric, please let me know. So these are the common types of holidays. We have a true holiday, which is just a void. So we have an opening from the substrate through the coating to air, and it allows the electrical current to get back to ground when you're running a holiday detector over it. We have despondment or an air bubble underneath. Most of the time, these are damaged to the point to where we can get an arc to pass through that void. Then we have the raised lamination or a sliver. Something's under the unit. Raised lamination a little bit different than despondment. Weld splatter is always a headache, especially around joints on pipe or even on tanks where flanges come out, flange fittings come out. And then foreign particle, and it can be anything from blast matter to just about anything that gets between the coating and the substrate. So that does it for the missteps on ground, and that following the manufacturer's guidelines. So coating manufacturers their guys sit in a lab and they spend a lot of time determining what the test voltage on holiday detector should perform on their coating. So they come up with these numbers and everything's great until they get out into the field and everything changes. So in the real world, we have high temperatures, low temperatures, high humidity, low humidity. Barometric pressure can change the way electrons flow out of a holiday detector. So this is where we get back to creating a holiday, finding that holiday and determining what the proper test voltage is for the environment you're in. Again, weather and soil conditions, super dry soil conditions can affect holiday detectors as well. So every coating inspection job is quite unique. The ground resistance, again, the weather at the time of the inspection companies. We've had inspection companies, I mentioned one earlier, where this inspector had actually closed down a line, 400 employees went home that day. We got out in the morning with a detector, found out that this inspector had no experience, they had no training, and they were on a rather important project delivering water from Northern California down to San Diego. And she didn't even have a tip gauge to do dry film thickness measurements on the surface. And again, that slides down to the next problem, that is training of the personnel. She had absolutely zero training, and she sent 400 people home on that day because she didn't realize that the coating was too thick for the voltage applied. Treating SPOs as if they're gospel. So here are a few standards that NACE puts out. ASTM, there's also standards put up by the Australian government, their standards group. The Japanese have a standard, and they're pretty much the same, but they do vary. And the one thing they don't account for is weather, grounding conditions as far as dry soil, concrete. If you have a moisture level in concrete that is I think it's below 7%, you won't be able to get a holiday detector to actually go through the concrete back to the ground. So a lot of the standards or recommended practices don't account for the conditions that the real world substrate is in. So we try not to treat these as gospel. And then again, reading the instructions before you start your work, it's imperative. You read your spec manual for the job. You read the instruction manual for the mixing of the coating, and you read the instructions for the equipment that you use. Not just holiday detectors, but every piece of equipment you use. You should be pretty thoroughly educated as to how those work. So with that. I'm going to have to field some questions if we're going to chew up any more time, because I'd like to thank you for this opportunity. It means a lot that PPG included us on this webinar. We hope that you've gained some knowledge out of it. If you ever have any questions, that's who I am and where I am, and you can always contact me for direct questions about this subject. And I thank you very much. The next slide is going to be the QR code that Tom talked about. If you'll hover your phone over that QR code, that'll link you to the survey. And I think Tom can talk a little bit more on that.
Yes, the survey takes about a minute and a half to do. It gives us good information on your thoughts on the webinars, and plus you have a place to put comments on future webinars or ideas on webinars that we've put on. We've put on a lot of different topics so far, and so we're open for ideas on other topics. So please do the survey. That really helps us. So does anybody have any more questions you want to type in? Questions? I don't see any more questions for the time being.
Tom, I know that Tim Bieri's in the room. He's got to have a question. Tim's never not had a question.
Here's a question. Any links available for case studies and/or examples on common pitfalls, things to think about, usually only obtained after years of experience, do's and don'ts? You have any kind of list like that?
I could probably come up with one pretty quick. One of the things we do not do at Tinker and Rasor is we do not recommend test voltages. And the reason we don't do that is because we just don't care for lawyers. If I tell you to go out and run 35,000 volts on a 5 mil coating, and you get a lot of sparks all over the place, you're going to come right back to us and blame me. And to be honest with you, I just don't need that headache. So that's why we rely, and I kind of, I'm not really joking about the reliance on standards and coating manufacturers' words, but they're an excellent starting point, if nothing else. I know that, what is it, 188 Tom says if you're testing between 11 and 15 mils, you should be at 1500 volts. That's fantastic as long as you're not at 40 degrees below zero and zero humidity. And things change when you're at 100 degrees and 100% humidity. So, pulse type. Go ahead, Tom.
What standards do for you is they kind of give you a reference point. So you can cite the standard, but you always want to refer back to the manufacturer because it's not always going to work like you want it to work. So a standard allows you to cite something and not have to be detailed because the standard is already detailed. So that kind of gives you a good way to put something in a spec and you don't have to explain it because it's already in the standard. Tim did come up with a question. What are the key safety concerns for high voltage versus low voltage?
Well, we joke around about the new guy and holding onto the ground wire and allowing the current to go, the voltage to go through. One thing that we educate everybody on that buys our equipment is that we are an extremely high voltage with a very, very low current. We're well under muscle lock for the OSHA standards in the United States. We would recommend you wear gloves if you have them. Stay away from the hot end of the holiday detector. It's never fun to get bit. Never hold on to the ground wire while you're testing. And let it drag behind you. That's how it's designed. That's what it should do. And as far as low voltage, if you're talking about 67.5 volts, you can't feel 67.5 volts out of a wet sponge detector.
Very good. Another question by Leonard. Do you have any pros and cons when it comes to using conductive primers?
Ooh, depends on the material. I know that we do a lot of work with clients that have businesses that go out and recoat sewer systems. It's a big deal. And in some of the cities, they mandate holiday detection, but their manholes are made out of brick. And last time I checked, you can't pass current through a brick. So we know that some of those companies are using conductive primers and having pretty good success with leaving a tab out to grab a hold of that conductive primer. You cannot test with a holiday detector any type of conductive, zinc enriched or go back to my days of the lead based. You just can't do it. Current will pass right through the coating.
Right. Yeah, I wanted to. Yeah, I'm glad you brought that up. People ask about zinc. You can do holiday testing over zinc, but you're only testing to the zinc. So if you have coatings on top of the zinc, you're only testing holidays on the coatings that are on top of the zinc because zinc is conductive. It's not magnetic, so you can do dry film thickness testing, but you can't do holiday testing of the zinc.
Right.
So,
right. Yeah.
And then we have another question here. How should hoppers be tested? I assume he's talking about hoppers that carry things, I assume.
Sure. So there are many different types of electrodes used in holiday detection. You'll see in our slides, we show on the pipeline a full circle spring electrode that goes all the way around the circumference of the pipe. But we also, on the wet sponge, we use a wet sponge that we hook to the unit, and it uses water to bridge the air gap between the top of the coating and the substrate, finding holidays. 0 to 10 mils tap water is fine. Anything over 10 mils to 20 mils, which is about the top end for testing coatings with a wet sponge detector. We like to use a surfactant in it. We use some chemicals that come out of the photo processing industry. It's a sudsless surfactant, so it doesn't cause a bunch of suds all over. Dishwashing soap works very well, except then you have foam everywhere, and it's never fun on the job. So.
Yeah, Yeah, so basically, if it's 20 mils or under, the safest thing to use is the sponge holiday detector.
As long as you're talking spray applied or roll applied coatings, yeah. Some of the tapes won't allow you to use wet sponge. The water won't penetrate fast enough.
I don't think any tapes are used in the hopper cores or anything. So
yeah. So your question about the hopper is, we have, every manufacturer has an electrode that should fit your need, whether it be silicone brush, wire brush. On the lower end mill thicknesses, a wet sponge can be, you can design your own, really. Just get a good cellulose sponge and cut it to shape. So.
Very good. All right, I believe Mark has a demo now, and give him a little time to set that up.
Yeah, so what we're going to do is we're going to try. See, Tom, I do this backwards every time. We're going to move our camera around a little bit and show you what we would consider basically a conductive substrate, non-conductive substrates. So there's our whiteboard in our office, and we can take the holiday detector, and where the whiteboard is, of course, it won't be conductive. We turn the unit on. We make sure that we have a good ground to the base. And as we wipe with a wet sponge, we always go over the same area twice. So we move over. This sponge might be a little dry, but and then we move it over again. Same spot twice every time. When we hit a holiday, we'll get a good indicator here. Yeah, that sponge is very wet. So we get a good indicator here and a good tone. So if you're in a really noisy environment, you may not be able to hear the detector. Most of them come with earphone jacks, but you get a good visual indicator on the detectors as well. So again, non-conductive because it's coated, and then conductive. So that's the fun of wet sponge holiday detectors. Then as far as high voltage goes, and for the gentleman with the hopper question, this is a wire brush, so it allows the wire to move out of the way. So if you've got uneven surfaces, even rough coatings, it'll allow it to go up and over the bumps and bridges, if you will. So what we do is we want to turn the holiday detector on. We've already adjusted the voltage on it. We turn the unit on. Now the side edge, I don't think I showed you, the side edge won't conduct because we have an air gap at the bottom and top. But with high voltage, it'll bridge that air gap. Or we use water on the surface of the sponge type electrode. We're using sparks to bridge the air gap. You'll note that this is still kind of wet, and even though we get very close, the water won't track pulse type DC. Pure DC will track through the water and right to a holiday that you've tested 3 feet over. So in the rain, we use these quite often in the rain. So again, non-conductive. And then we come over to this edge, and we get a good solid tone and an indicator on the light, and then go back to this ground, and here you go. So that's the difference. We're actually using an arc to bridge that air gap, not water, or water with surfactant. So that is basically the difference between wet sponge and high voltage.
Very good. Anybody have any questions? Any more questions? All right. So what we're going to do now is we're going to send you some poll questions. We have 5 questions for you to answer. They're all multiple choice. So I'm going to launch that poll now. And we'll give you about 5 minutes to answer the questions. And then when we're finished, Mark will give you the correct answers for those questions. So you should see those now. Okay, we're going to end the poll now, and we'll share the results and let Mark go through the questions and give the correct answers here. So share the results there. Okay, Mark.
Okay. So anybody that answered all of the above, you're not wrong. But the first thing that we like to do after unpacking the detector is to make sure that it's complete and that all of its contents have been looked at, verify proper fit. So the answer actually would be inspect the contents for issues and ensure proper fit. All of the above is a good answer as well. Charging the battery, I do after we make sure that we have a battery in the box, and always head out to the field with a fully charged battery. Item number 2, what determines the proper test voltage? Mil thickness of the coating and enough voltage to bridge the air gap. That is correct. And then the strict adherence to standards, of course, we spoke about how those are just guidelines, really. Once you get out to the field, everything changes. The best way to assure that the user is locating defects in the field is to actually create a holiday, is the answer to that one. Number 2, and we want to make sure that that arc, if it's in a high voltage detector, we want to jump twice the distance as the coating is thick. Wet sponge, we want to make sure that we're able to penetrate that holiday on at least the second pass. Okay. As far as number 4, the most common missteps in a holiday detector. Again, all of the above could be the right answer, but improper grounding is the number 1 problem that we hear about from the field. Either one of those would be good. Too high a voltage, of course, is a problem. Too low voltage is a problem. But the proper answer would have been improper grounding. And the most common ways to bridge an air gap between the electrode and the substrate is all of the above. So spark on holiday detectors to make sure that that's set high enough. Tap water is good to anything on a spray applied or roll applied coating on any substrate up to 10 mils. The water with surfactant is good for anything over 20 mils. So there are your answers, and I'd like to thank you all. Tom, before you go on, thank you all very much for showing up, I hope you're not shuttled in your houses for too much longer. Get out, go to the park, get some sunlight. And again, if you have any questions, you can always contact us here at Tinker and Rasor. My phone rings. I don't screen any calls. So I'd be happy to take any phone call or email.
Sounds good. A couple more questions. Leonard asked, I dislike the newer sponge electrodes. Is it possible to still obtain the older style that simply clamp the sponge electrode? I think he's talking about the old M1 model, I assume, that has the clamp with the wing nut.
Leonard, I thank you for that, and probably because it was my decision to change the sponge style, and we did that because we got a lot of complaints about the clamps. So, it falls into that old adage, you can't make everybody happy. If you'll do me a favor and email me directly, I'll see if I can't find some clamps and sponges around here that we can lay off to you, no charge.
Yeah, if you don't have his email, you can send it to me. I'll forward it to him. So, what is your email? If you'll just give that now.
Sure, it's very simple. So it's mark@tinker-rasor, Rasor.com.
Mark@tinker-rasor.com. Very good.
Right.
And then Roberto said, thank you for the session. Tim has another question. Why not use the holiday tester to set the voltage, create the holiday, then back off a certain percentage?
That's exactly what I said, I hope. Because that's brilliant, Tim. It's brilliant. But I think I said that. So what we do is we want to make sure that arc jumps twice the distance across the coating as that coating is thick. So if the coating is 1 inch thick, we want that arc to jump 2 inches across the coating before it goes down the hole and touches the substrate. So a total of 3 inches, if you will.
Very good. Says use the holiday tester to burn the hole is what he's talking about. So just turn it
Oh.
all the way up, create the hole with the holiday tester, and then you'll have your holiday.
It's very rare for you to be able to burn a hole in a decent coating with a pulse type DC holiday detector. We can do it, especially on brush or roll applied coatings. We can dial it up and let it sit there long enough. But we've taken 10 mil pipe wrap, for example, and wrapped a piece of pipe and left it on there full blast, 35,000 volts, 24 hours, and never damaged that pipe wrap. So it depends on the type of coating that might work. So.
Yeah, I think it'd be very tough to do that with epoxies of any kind if they're decent epoxies. The real thin film coatings, maybe. All right, Tim says perfect. So good. I have a question for you. There's some conversation around a pulse type and constant current type holiday testers. What are your thoughts on those?
Well, we don't make a straight or constant DC unit, and then we don't do it for a reason. Number one, our units are made for in-field use. They spend a lot of time in inclement weather. Pulse type DC will work on a rained on pipe without sounding off to a holiday that you found, a minute and a half ago. There's no tracking of that voltage across the pipe. I think that higher voltage straight DC, it's my opinion that it's inherently more dangerous. You don't have that pulse to allow you to unlock or drop the instrument if you get tied up in the ground wire or in the unit itself. A lot of people say it's better on concrete, maybe, but we have extremely good success with pulse type DC on concrete. So.
Okay, very good. Good, great answer. Great. I learned something from that. So it doesn't telegraph like a constant current would when there's moisture involved.
That's correct. That's correct.
Good. All right. Any more questions? So I'd like to thank everybody for coming out. Please take our evaluation survey. You'll get an email tomorrow. If you're an engineer, by the way, or if you need credit hours, you can get an online certificate. You'll get an email tomorrow. It'll tell you how to do that. It'll give you an email address. You'll send your request, and it will send you an online certificate for a 1 hour credit hour for this session. So we do have that available. So thank you very much. Stay tuned. We'll have some more webinars week after next lined up. We've already got the topics lined up. So we're going to continue to do this how-to series. So thank you very much. Have a great day, everyone. Thank you.
Thank you, everybody.
Thank you, Mark.